Thanks, Akhil. Thanks for the clarification.
Second, Srinivas, one quick question. So yesterday we were talking about this value streams, right? Yesterday we were talking about this operational value stream and development value stream.
Perfect. Yeah.
Okay. So now in the overall SAFe, or when we are talking about this agile train, actually, a complete train, or in the SAFe, how are we going? Where exactly this development thing will be coming on, or operational value stream will be coming on? How we are going to align, or the big picture is what are we going to look at?
Principle 10. Yeah, principle 10, which we'll do today. That's the principle. And something which I showed yesterday, just a good reminder, we plotted our development value stream. And I said that we will have agile release train, which should have people who will take care of all the steps and deliver the product. So ART, ideally, agile release train, should be aligned with development value stream. So you give a request to the feature, to the ART, and ART produces the feature in the product. That's the thing. Your operational value stream is not managed in SAFe, it is your hierarchical organization. So as we learned, the departments, the banks which are running the business, the individuals and key stakeholders from operational value streams are expected to be participating in the activities done inside the development value stream. And development value stream, for all practical purpose for us, is equals to agile release stream. Yeah. And we have a principle 10 which we'll talk about in a little more detail.
Okay. So this operational team, whatever, this team will also be participating in all the activities like PI meetings and other everything.
Key stakeholders. So you can say that maybe you need to identify some 4-5 members from the business area, and we call them business owners, and they are expected to participate in PI planning, demos, reviews, because they are the one who really know what is needed in the business. So we call them business people or business owners, some stakeholders.
Only these business owners will be attending those.
Perfect. So key stakeholders. Yeah, we need to identify who are those. So we need to identify ourselves. The SAFe can't tell it, but yeah, some people need to keep it.
But from the development standpoint, the complete ART team members, complete team members will be attending from the
Yes.
development standpoint.
Yes.
From operational, it is only key stakeholders will be attending. That
Yes.
is the main difference.
Yeah. And
Because
they
this
should
is
be
more of
named
a
business.
service oriented, and that is more of a development only.
Yeah. And that those are named stakeholders. You need to have named stakeholder list for them, and you call them business owners in the lead.
Good. Perfect. Thanks.
Perfect. Anything else, anyone? I hope some of you got a chance to see the Principle 6 videos. Yeah. Anyone? Well, maybe thumbs up. Yeah. Who saw
Yeah.
the video, Principle 6?
Saw some.
I got to go through it. Quite a lot of things are related to lean. The terms that you use, like batch and inventory, are related to lean.
Yeah, good. We'll touch upon them in more detail. Thank you. I think 4 or 5 of you have seen it. It's a great help. And we learn as we go along. Yeah. So plan for today, I start with principle 6. Then we have a principle 9 and 10 also. 9 talks about decentralized decision making, and 10 talks about creating agile release stream aligned to development value stream, something which I was discussing with Srinivas. So that's the principle number 10. Once these 3 principles gets over, I hope they gets over soon, and we get to the framework fast. In the framework, we will learn about the roles, lesson 3, agile team, release train, and how agile team operates, Scrum process, Kanban process. That's something we will learn. And then we initiate our lesson 4 talking about feature discovery and prioritization of the features in the ERT backlog, and finally maybe a little bit introduction of PI planning meeting. So that's the plan for today. Complicated topic is the first, principle 6. That's a complicated topic to start. And we will also take another complicated topic before we finish the class, which is called WSJF, prioritization using some lean economics principle number 1 ideas. So that's another thing we will close with. Both of these things are available in the video, but yeah, we will talk about them in the class as well. Feel free to raise your question if you have any, and I start with the principle 6 now. Yeah. So make value flow without interruption. See, the idea is the principle 6 is aggregation of Kanban and lean ideas in SAFe. In the SAFe version 6, they have made it little bit more detailed, but whatever is coming in the SAFe version 6 here was part of Kanban way of working from last 20-30 years. It is nothing new. Indirectly, whenever we were talking about 3 elements of this thing, which were also covered in the video, those 3 elements are expecting that other elements should be there in order to smooth the flow. So now in the version 6, they have little bit repackaged the whole content and stressed more on uses of Kanban ideas throughout the SAFe. So they are saying that we need to focus on ensuring the flow. Now what is flow? In a simplest word, we have our value stream which is moving, and we have a trigger, and we are producing the delivery. We learned about terms like value stream map and other things. The flow is all about making the value flow fast, removing the delays, so that from here to here, the time is less, which is also called lead time. So like we learned in our lean thinking principle, that remove delays, remove everything, so that flow is maintained. So that's the whole idea. The principle 6 is also reminding that we need to make our flow fast, and we need to take care of the flow and pursue perfection in the flow. Now in order to achieve it, in the new content they are saying we can use 8 flow accelerators. So these are the things which can help us in optimizing and making the flow faster. In this class, we are only getting into the details of 3, which are also covered in the video, but there are others which you can learn from scaledagileFramework.com. So scaledagileFramework.com is your go-to place, not needed for leading SAFe exam passing, but for your future reference. I just wanted to show you so that you start getting a little feeling of it. So whenever you go to scaledagileFramework.com, you can find all these materials. For example, if you want to know about SAFe principles, you click here, and then you can start scrolling down, and they will talk about various principles, and you can also find the detail related to those principles here. I think somewhere I can click here, and then I can get the whole idea of principle number 6, which is very, very elaborated content where they are explaining all the flow accelerators. So someone who wants to prepare well about SAFe at a later stage, I do recommend looking at these content. Even if you are not using SAFe, still it's a good content. It is good content, and it is not something which is discovered by them. It is compiled by them. It is something which was already there in the Lean Kanban books, but now it is here, and many times they give a reference of those books also from where they are picking up. So this whole content is coming from somewhere here. Yeah. So it's a good place to check the details for your future reference. Now coming back to the idea. So they are saying 8 flow accelerators to visualize and limit working process. So which is like using Kanban board, so we can see what is happening there. So we look into it in detail. Addressing bottlenecks is more about identifying where the flow is getting stuck. The bottleneck is something like in the whole flow process, you identify where there is a stuckness. There is a possibility that things are moving fast till here, then they get stuck somewhere here, and then they start moving fast. So we don't get into the details of that particular concept, but that's the obvious thing. We need to identify those bottlenecks and resolve them. We need to do something, maybe add people to this bottleneck, or find a way to bypass this bottleneck, or do some redesigning so that these bottlenecks get removed. So that's the flow accelerators. Minimize hands-off and the dependencies. So by way of creating, like the Srinivas point, by way of creating one agile release stream, which takes care of complete development value stream, we are minimizing the hands-off, which means it's not like one department is doing A and then it gives to a second department. Making common team delivering it, try to make people multi-skilled so the same person can do multiple things and finish the work rather than always dependent on each other. So in order to improve the flow, we need to focus on how the complete work can be done by less number of individuals so that we have less dependency. That's the idea of optimizing the flow. Get feedback faster. So as we learned in our principle 4 yesterday, we we need to follow shorter feedback cycles, we need to follow the cadence, principle 7, that ensures that we have a mechanism of learning back at a faster pace. So that's a get feedback faster, that optimize the flow. Work in a smaller batches, so we'll learn about it more. So do small items so that they passes through the value stream fast. So say you can visualize value stream as like a pipe. If you have a small item, those pipe the items may pass through the pipe easily. But if you have an item which is big, which is near to the diameter of the pipe, then there is a possibility the item may get stuck somewhere and then it will block the whole pipe. So we need to focus on creating small items as per our pipe. Pipe could be our capacity of the team. Yeah, that's like pipe. And the item is which is going out, work items, features which are going through that pipe. They should be of a smaller size so that they can keep passing. That's principle number 5, area number 5 as a flow accelerators. Reducing queue length. If you have a lot of items pending, you have to-do list, and if the to-do list is too much, which means you have a more demand than capacity, then also your flow will be blocked because people keep coming, they keep asking for various things, and your team is not having capability to deliver it. So the idea accelerator 6 talks about we need to manage demand and capacity. So 1, 5 and 6, we have a little more elaborated content as well in this particular space. Optimize timing in the zone. It is basically focusing on reducing multi-skilling, making people to finish one work at a time rather than keep switching from one place to another place. So if you are working in a one area, you need to finish that and then only move to the next thing. So optimize in the zone time by way of allocating people 100% to a given work rather than distributing to the multiple work. Now, remediate legacy practices and policies, so it's more about keep optimizing, keep reflecting on some of the old practices which might be becoming blocker for our flow. So keep reflecting on our ideas to keep improving and pursue perfection. So these are the 8 flow accelerators. Simple content, existing content, but now it is added in the SAFe as a SAFe 6.0 update. These are the 8 flow accelerators. Any comment before I get into the details of 3? I have been recommending people to go through Kanban programs because if the SAFe you want to understand well, and Kanban is useful without SAFe also, so that's a good thing to do. Someone was speaking. Go ahead. Yeah.
So the last one is like following the practice and policies is. Can you please elaborate that more?
So it's more about like you need to keep updating your past practices. You need to improve them. Like that relentless improvement, pursue perfections is all about that we need to get away from things which are blocking our flow.
Okay.
Legacy practices.
Okay.
Good. So we start. Yeah. Okay. Visualizing and limiting work in progress. So here, very simple representation. I am assuming most of you know what is Kanban board, what is Scrum, etc. The idea of this presentation is that in many agile teams or in the SAFe world at a team level, ART level, even at a portfolio level, we expect to create a visual status or information available of work which is happening in the team. So many times this is presented in the form of a Kanban board where you have a workflow and work made visible. Now, not started, development, test. So these are stages. You may have a 10 stage, you may have a 3 stage. This is just an example. And story 1, story 2, story 3, this is the work. So when you see these kind of a board, you know what is where at a given point in time. So for example, here you can see there are 5 stories in development, there's a 3 stories in testing, and there might be a 1 story which is accepted and 2 stories are not yet started. We can say, oh, this is a Kanban board of a team, which now we have a little more information. This is something that you have a 3 days left in the iteration, and this is your status. Now, what do you do when you have a 3 days left and you are at this particular stage? You may say that, okay, things like not looking good because in the just 3 days, everything moving towards the done stage may look little risky. Yeah. So that's a visualization and making Kanban board. Now, the other thing is, how do we improve the flow? So the one of the practice after visualization, which is promoted here, is limiting work in progress. So there is a small presentation with the help of activity. where we show how possibly limiting work in progress can optimize your flow. So let's see it. So here we are saying that this is your team Kanban board, the previous one. We'll go there again. And let's discuss how the limiting work in progress of 3 might impact your throughput, your finishing date. So we have a consider a scenario. You are a developer and you just finished story 6. What would you do in 2 cases? You don't have a WIP limit and you have a WIP limit. So let's see in a little more detail. Say I am done with the story 6 and we don't have any limitation. Yeah? Then what I will do, I will say, guys, take it for a test. Simple. And most likely I will start working on new work. I will say I will work on a 11 story 11 because pending for me. But if I do so, if my developer does so, and that too when there are only 3 days left in the iteration and we are at this stage, how we can remind him or her not to do so? Because the probability of this work getting finished, developed, tested, and accepted in the remaining 3 days is less, especially when you have so many pending testing, you have so many ongoing development happening, and we are assuming everything is of a similar size. There could be an exception where work is very small, but we are assuming work is of a similar size, then the probability is very less. So how do I remind my teams not to start a new work? That is my problem as a management, or how do we optimize that process? Yeah? Because we believe in such scenario, if the new work is getting started, that will not get finished, and that will be a waste at the end of a sprint. Now, one of the possibility to block this behavior is we can say we have a WIP limits, work in progress limits, and assuming I put a work in progress limits of 3. And because of whatever reason, it is already red. It is already violating the work in progress limits because you already had a 5 work in progress. Assuming now I am done with story 6. Yeah, same case. Now I can't move it to test because there are already 3 items in test. So test people will not start. They will say, we need to wait for something gets over before your work can get started. So the first reminder which will be given to the developer is, can you do something to move this test to the done? If yes, your story may get started for testing. So developer will have all the incentive to work with the testers to move something out so that something gets done. Now, if something goes out here, that's a great thing because something got finished at the end. So if that happens, that's a good thing and the story moves here, we can say we are helping the flow to move. Assuming the developer is unable to do so because he may not have a skill in testing, or even if after done that, he has a time available, what he does. Now, second possibility now developer can do is, he may want to pick up a new work, but he has a WIP limit of 3. He can't pick up. The WIP limit is, let's keep the work in progress to a limited stage. Now it will give another reminder to a developer, can you work somewhere else? Can you help someone else to finish the work? And if that happens, that is again a good thing because we are helping the ongoing work to finish before we start a new work. So the idea of work in progress, again, it's a very simplistic explanation, and it is not a safe idea. It's a pure Kanban idea. It was there from before the SAFe even called SAFe. There was no SAFe, still this idea was there. And this idea is primarily focusing on that you need to finish something before you start something more. So limit the things which are ongoing, make things completed, and then you start new things so that we have a flow of work happening. If you don't do so, you may start many items, but you are not finishing anything. Not finishing means your end users are not getting it, the feedback cycle is not completing, and that will delay the whole, say, lead time. Lead time will become high because a lot of things are getting stuck in between. So that's the example and small presentation of showing visualization of work and workflow and limiting work in progress. First part of the one of the 3 things which we have to discuss in this principle number 6. Good. If this is done, there are a lot of graphs, I know, and these videos I'll let you check later, but there are 2 graphs which I need to explain, and the concept of queue. Good.
So I have one slide. Can you pull up on that slide? Yeah. So in this development state, if suppose like due to some external dependency, some work is stuck here only. and due to that we have like due to that only we have crossed that work in progress limit. So then in that case, what should we do?
So you need to define that. You need to define as a team policy. So for example, do you count the work which are blocked by the external dependency in your work in progress limit, or you exclude them? Many times people exclude them. They don't count those things as a work in progress. But depending upon the advantages and disadvantages, advantage is that you can use your productivity to something else rather than keep waiting for something which is blocked. The disadvantage is sometimes you may lose focus of resolving that dependency because you got busy. So depending upon your situation, the Kanban tells, SAFe has no idea here, Kanban tells depending upon the consequences or the impact of counting or not counting happening, you need to decide what would you like to do.
Okay.
Okay, great. Now, second set of graph. This graph is trying to promote having small batch sizes. So better we do item in a small pieces rather than large. That's the idea. Now why? It is showing the two parameter, cycle time, or you can say variation in cycle time. So predictability variation. You predict that you will do it. Low variance means you always meet your commitment. High variance, 50% variance means 50% time you don't meet your commitment. Yeah, that's like a variation. So here is the variation. And this side is a planned utilization, which means number of hours which are available to you and planned for productive work. Utilization planned for the team. So this graph is showing if you have a small work items going, yeah, even with high utilization, still the work variations are less because items will get finished. Yeah, even if you are trying to fill your work, your day well, yeah, too many tasks are planned. But if your work items are large, yeah, then there is a variation will keep start increasing as you start filling your day, yeah, as a more utilization. Because in the big item there will be variation, and if you don't have a planning done for those contingency, then you will have a poor predictability of your work. So the point which this graph is trying to make is if you want to utilize your people, your resources more, and at the same time you want to have a predictability to your end results, it is always good idea to make a small items so that small items get done, like creating small tasks, creating small stories, creating small features, so they will get done and you can maintain a higher utilization as well. The example which I used in the video, I give it here as well. Say I am planning my day. I have 8 hours available, and probably I only want to plan for 7 hours. So I am keeping some 80% utilization. I'm saying let's not plan 100%. I'm doing some less utilization planned. So one scenario, I planned 7 1-hour jobs. Yeah. And I start them during the day. Most of them are getting done. Maybe few takes more time, 15 minutes more. I had a contingency of 1 hour. Maybe one job gets stuck. Still, there is a high probability I will finish 6 out of 7 because they were only 1-hour jobs. Even variations happening, they can be managed. I will say, okay, at least some 80% work has been completed. Scenario 1. Scenario 2, I have 8 hours. I am planning my 7 hours only, but I only plan 2 tasks. One is of 4 hours and another is of 3 hours. Now I start the 4 hours task. Since the task was big, the variation, even if it becomes a 20% variation, it will be another half hour, 45 minutes, something like that. I get a variation, this 4-hour task may become say 5-hour task, yeah, or 5.5-hour task. I can say, okay, I finished it. Then I start the second task. I already running out of time and this task may take a little more time. There will be a situation the second task is not finished. Now, in this case, what happened? I had 50% completion at the end of the day because I planned 2 things, I can only finish 1. So the end result, the finishing is where the end user gets it, end user is not getting it. Even if a 1-hour job left or 15-minute job left, the end user is not getting it. So what is the summary by simple example? We are saying that if you want to make lots of work in a day and still want to have a predictability, it is a good idea to create small work item, which is a small batch sizes. Because of whatever reason, if you can't make a small work item, then keep some more contingencies because big work items will take time. Don't plan too many things. when you are planning some big items in your day. Yeah? So that's a graph telling, and it is primarily promoting we should reduce the batch size. Now, what is batch size? Anything which goes to plan to checkout cycle. Anything. That's a batch size. A user story, define, design, test, finished. It finishes the whole batch. It's a batch size. So small user story is a small batch size. Big user story is a big batch size. Anything, maybe making a customer releases, again a batch size. Small features get discovered, small release get planned, deployed, tested, validated, feedback collected. That's also a batch size. So small batch size, collection of few features goes to the release. Big batch size, we accumulate a lot of features and then we send to a release. So depending upon the context, the batch element might be different, but we can equate batch size equals to anything which goes from the cycle of identification to completion, and there is someone who can say, oh, I got some value at the end. So if we keep the work item small, our predictability will be high. Yeah. So that's the another idea. Now somebody will say, what do you mean by small? Yeah. Is it 1 day, 2 day, 1 hour? How small the user story should be? Should we have 2 pointers user story, or should we have a 13 pointer user story? Now that answer cannot be given, and for that answer we have another graph, and we call it finding the economic batch size. So these are few videos which helps you in exploring the batch size idea. I'll let you explore as a homework, but I want to talk about now the economic batch size. Yeah. These ideas will come in your exam. So large batch increases variability. I try to explain, but that's the English about it. Higher the utilization increases variability. So if you utilize yourself 90%, 100%, there is a chances that you will miss things. Many times project will slippage, and that will delay your overall delivery. So the solution is create small items, small batches go through the system faster with less variability. That's a statement. And many times when the work is moving from one person to another person or one department to another department, those batches becomes more important. So for example, your business releases may becomes more important because they are going beyond agile teams. So agile teams gives to the business, business gives to the market, market have a feedback to it. So those batch size becomes more important because multiple parties are coming in between. So the important batches are the one which has hands-off batches. Yeah. So that's the English about what we explain in the batch size and percentage utilization. Good till here? Then I talk about this third graph here. I use the simple presentation first. So now the question is, you got the concept that okay, batch size should be small. Now you are trying to find out in my company how frequently I should release. Should we release as soon as we finish a one feature, or should we accumulate 10 features together and then release it, or should we do a release once in a year? Yeah, which one is right for us? Again, I spoke about small batch size, and someone spoke yesterday, it should be economical as well. So which one will help us in making more money? One feature, 10 feature, or once in a year release? That is what we are trying to explore, with mixing with the principle one. So this principle is reminding that, okay, to do that, we can explore as a economic parameters of two areas. We can say we are putting the batch size as a one parameter, one side of our axis. So say number of feature released one at a time, or maybe you accumulate 50 features and then you release. That's your x-axis. The y-axis is cost, the impact of doing this as a financial impact, the money you spend because of one release or money you earn because of one release. That's the thing we are focusing on. So money, cost associated with the release. So now we have two types of cost. One type of cost is called transaction cost, and many times transaction cost reduces with increase in batch size. Now what is transaction cost? So transaction cost is like cost of taking item from development to production. Maybe say regression testing, maybe end user training, maybe compliance documentation, maybe data migration, all the things which you do in order to release the product. That's the transaction cost. So, if you are doing one feature release, you need to do a transaction cost. If you are doing 50 feature release, then also you need to do a transaction cost. Now, many times you may have a process. This graph tells that even one feature you will take a 10 days regression. With the 50 features also you take a 10 days regression. Then you will say, okay, so the cost per feature with the 50 feature will be less. So I can say I can send all the features in a one batch. So it will reduce my overall regression, user training, compliance documentation, and data migration cost. Else I have to do it for each and every feature 50 times. So that's why we are saying that many times the increase in batch size may reduce your transaction cost, the cost which you do for releasing. That's the one parameter. But somebody will say, looks like you were talking the reverse before this. So now looks like everything different. But there is a problem. There is another type of cost which goes high with increasing the batch size. And this cost in this terminology, in the SAFe Principle 6 terminology, is called holding cost. So what is that? Cost of not releasing. Say missing revenue. Maybe you can make some money because of that product. Delay in feedback. Risk of or say like delay in validation, in a way still a feedback. So whatever you are losing because you are accumulating features, that's a holding cost. So if you keep accumulating, you have a more risk you are taking to the future. So we need to find out what is our holding cost. And based on these two parameters, again, this graph we are presenting is an example only. You will have your unique nature. We can identify the overall, I would say the overall cost, or say total cost, which will be a sum total of it. And we can say, okay, for a given situation, this seems to be my right batch size. So here, my cost of transaction and cost of holding is balancing, and looks like for me, I need to accumulate 10 features and then release it, because I need to make it logical as well. So economic batch size, now what we are doing here is we are finding economic batch size. So economic batch size is a balancing act between the cost of releasing, cost of doing transaction, and the cost which or the benefits of having the product or a market having that particular new feature in the early stages. So we need to balance the cost and benefit of release and find out what is our economic batch size. Any question till here in the economic batch size space? The impact of this evaluation could be we identify our business release cycles, product release cycles. Okay, now going back to the previous discussion, we want to have a smaller batch size. So somebody will say, how can we make this move left, somewhere coming here? How can we make this economics shifting towards this? Because we want to have a small batch size, because there are various advantages with it. So SAFe tells, in order to do that, you need to play with your transaction cost. So which means, by way of doing some automation, you need to bring your transaction cost at such a stable state so that they are more and more free from increasing the number of features. So say your regression is automated. So it doesn't matter you are releasing one feature or 10 feature, you can just run the automated process and it is taken care. So if your transaction cost gets shifted, like the one I have showed to you, then what will happen? Your new economic cost will also shift towards left side. It will be purely dependent on something like this, because it is primarily driven by the holding cost now. So your batch size will become smaller now because your transaction cost is stable against the x-axis. So by way of doing better automation, we can move our batch size to a one feature side, because now our transaction costs are less. But SAFe reminds it that don't bring it towards the left side till the time you don't have an economic batch size behaving like that, but have a long-term target by way of automating some of the repetitive process you do for deployment and release, so that you can do a frequent releases. So that's the idea of last segment of economic batch size. Okay, so this was the same thing which we discussed in the videos as well. That's what we are saying here. So again, they are just representing what is the total cost, higher the transaction cost. So now sometimes statements becomes tricky. For exam, you need to pick up the statement as it is. So higher the transaction cost makes the batch size is bigger. The higher the holding cost make optimum batch size smaller. So you are moving from this direction, that direction. It is just trying to show you the impact of these movements. And we can say that we need to reduce transaction cost to reduce the total cost and bring the economic batch size towards the left side. And it will help us in increasing predictability. If you reduce the batch size, it will help you to have a faster feedback because you are releasing things early. When you get a faster feedback, you come to know about your problem fast, so it reduces the rework. And you can also do a higher utilization because you have a small batch size. With the utilization also you can have a predictability. It also helps you in reducing the cost. So overall, if you reduce the batch size from 10 feature to 1 with automation, you will have significant amount of saving. And like they just put a statement here that the saving might be far more than what you are imagining. Many times the savings are underestimated. Only by doing this change you will see how much saving is happening. So you need to reduce the optimum batch size towards the left direction. Okay, any question, comment here before I take the final piece from this space, principle 6. So we just discussed two ideas. One is visualize your work and workflow, simple. And the second is that you should do a small work items. And in order to make that case little more, we brought some graphs and justification, and we were trying to convince you, I was trying to convince you guys that if you have a small batch sizes, they will help you to get higher utilization. And we also looked into the economics of creating small batch sizes, and we learned in order to create economically small batch sizes, you need to automate the repetitive work, because it should not happen that your testing teams does manual regression testing. It takes 10 days for each release, and you want to release each feature. Then they will keep complaining you that, guys, we are testing the same thing all the time. Why don't you give us a big chunk so that we can finish it in a one go? So they will be not happy, and it is not economical for you also to make people do the repetitive job. So how to do it? Either reduce the frequency. You can say, okay, I understand our manual process is there. We will do once in a 3 months only release. That's one thing. But you understand, if we have a big batch size, then our feedbacks are getting delayed and our risks are going, and we can't have a better utilization. So in order to make it more frequent, I need to automate. I need to improve my test process and delivery process so that it becomes automated, and then I can have a frequent releases rather than waiting for 3 months. So that's the point which we made here. It's all practically solving the problem, not focusing too much on theory. In a way, the principles guide us to take care of these various elements on a regular basis. Okay, so if this is manageable, the final piece of principle 6, which is getting discussed, is managing queue. So what it is saying is, say you had your Kanban process, you have limit your work in progress, and you can say anything will come, we will not start many things, and we will finish it because we are not doing many things. Great. But what if about your input backlog, which is not having a work in progress limits? So somebody will keep adding items here. Now, even if you are limiting your work in progress, but these backlogs may keep growing. And say, general Scrum example, someone asked you one requirement 6 months ago, you added that requirement to a product backlog, and someone comes to you and says, where is my requirement? You say, oh, it was not prioritized till now, and we are only taking the high priority item. But that person is already given it requirement to you 6 months ago. That person will be hoping that, this should be done. So overall lead time when the customer asking for a feature and customer getting delivery is still increasing. So what do? We need to balance capacity with demand. So for example, if our capacity is to do 3 feature per month or per sprint, and we are getting 6 features added in our backlog every sprint, new items, 3 getting removed and 6 getting added, we know we have a problem. And that will result into creating a queue. Yeah, there will be a queue in front of our work. Now what should we do? So the same frequents, we need to balance demand and capacity. Either bring item to 3, don't do 6. You can say these kind of work will not done by this team. Only such work can come, so that we have a demand versus capacity. Or you may add another team, add capacity. Yeah? You can say, oh, there is a one more team who will do this work, looks like we have a good demand. But we need to balance this. If we don't have it, then it will create dissatisfaction and lot of problems. So we need to manage, say, acceptable delivery time, which can be accepted by our customers. So that's the idea, and this we need to do by way of managing the queue length. We have not yet started working on it. They are still pending items, but still we need to keep eye on those pending items. So that's the idea which is presented here.
Saket,
Go ahead.
question. So now, how feasible is it of adding a team? Because for example, I have a product backlog, okay, and I know what is the estimate, right? Now, I know what is my team capacity, but adding another team, right, finding people and putting them is more time consuming rather than taking it to the next sprint. For example,
It's a temporary phenomena, then it's okay. But we are saying it's been a 6 months.
Okay.
Yeah, then only.
Okay.
If it's a temporary phenomena, then definitely adding people will create confusion, integration issues and all. You will say, it's better we do it a little less. We can manage customer expectation and delay it for a while rather than creating another mess. But if it's a regular phenomenon, then your customer expect you to deliver in a 1 month, you are taking 2 months. What will happen? They will keep complaining. So we can't continue with that complaint because they are expecting in 1 month and we are delivering in 2 months. So there could be 2 options. Either we stop doing that work and says, guys, don't ask these works from me. We will not finish into 1 month. Yeah, that's the thing. This is not part of our job. It will only done after 2 months, something like that. We remove the work. Or the company will say, oh, better we have another team to take care of it. Now it is all about business decision. It is nothing like right and wrong. Depends upon if the customer still sticks with you, then you are good. But many times customer will go away from you. If you are taking 2 months to deliver something which they expect in 1 month, your demand will automatically reduce. Yeah, they will go somewhere else. Yeah, that's the idea. So I gave an example of restaurant in my video where I tell, you have a restaurant and it has more demand than what you can serve. Then you always have a queue in front of your restaurant. Now what you should do, you need to do 2 of one thing. Either increase the price so that your queue get reduced, only few people come to you and you make more money from the same restaurant. Yeah? Then you manage the queue. The second option is you add 1 more floor to your restaurant and says, I will take care of the full demand now. We have 2 floors. If you don't do any of these 2, what will happen? People will be irritated standing in queue and gradually demand will go down. And you will not make money, the demand will automatically get down. And you have not increased the price, but still demand went down. Yeah. So we need to take care of it in order to have a long-term sustainability. Either increase the capacity or manage the demand. Now which one you should do, we don't know. It's a management decision making. Yeah. Good. Now the longer the queue, what are the problems from a theoretical perspective? So the queues create delay in a lead time. Customer reaching to a restaurant and getting food, that is getting delayed even if you have not got the seat, but your time starts as soon as you reach to the restaurant, so you have a longer lead time. It creates risk because the work items were pending and lying in the product backlog for very long. We have not discussed the whole product backlog well. So even if we are doing currently, it may have some ideas in the future product backlog items. So if we have many pending things, it increases the risk. And it also increases the variability because our understanding of those items may not be good also. Someone gave us requirements 6 months ago and we are doing it now, then we have a more chances of misinterpretation. Many times since we see we have too many work pending, people will start taking shortcuts and there is a high probability of lower quality. So we may bypassing definition of done and all those things. And your development team will also be less motivated. They will say, whatever we do, the customers are always unhappy. Yeah, we have done our best job, but customers are saying, guys, you are 6 months delayed. This thing I gave you 6 months ago and now you are delivering. I don't want to give a feedback on it. So it creates the overall poor motivation. Now, if these problems are your problem, then you need to take care of queue. If none of this is your problem, then your queue is good. And you don't have a queue as a problem. Again, these all are high-level ideas. You need to apply them whenever you see an impact or applicability of these ideas. So manage your queue length. Long queues are bad. Now, final thing in this theory of principle 6. So it is saying, how do we manage queue length? How do we balance the predictability or a delivery time? So they have a lot of ideas and heavy word, but it is simple calculation where you can say that wait time for a delivery is a function of work in progress, in a way demand, divided by throughput, which is capacity. That's it. So say, let's take an example. I'm a car mechanic. Yeah? I can fix 2 cars a day. And if I have a 2 parking lot, I only take 2 cars maximum at any point in time. So my demand will remain limited to 2. And I am the mechanic, I can fix 2 cars. So what will happen? It will be a 2 divided by 2. Work in progress is 2. And my capacity to finish car in a day is 2. So my customers usually get their product in 1 day. Now, assuming I get a little smarter and I create 4 parking lot in front of my car shop, then my work in progress, I can say I will take 4 cars for my work, but I still remain a single engineer. So I am still fixing 2 cars a day. Then on average, my customer will get the car in 2 days. Now, we are not saying 2 is bad or good. We need to see what industry is asking for. Is it 2 acceptable time, or it is 2 is too much? If it's an acceptable time, then I will say, okay, work in progress of 4 is good, because we can say that industry is also good with the 2 days of delay. But if you see the 2 days is not good, customers will run away. Maybe they by mistake give me a car once or twice, and afterwards they will not give. Then I need to manage my process in such a way so that I release the car in 1 day. So either I reduce my work in progress, I reduce my intake. If the 3rd car comes, I say, I can't do it today, tomorrow I will call you. If you want to still get it fixed, you can come to me. Or I hire 1 more mechanic, which is adding 1 more team, so that we fix the car faster. So we need to decide which one we want to go, but there has to be a balance between demand and capacity to achieve the industry acceptable wait time. That's the only thing we are trying to explain here. Yeah? So you need to keep that thing also in mind as a leader manager when you are looking at a process of your development, with safe, without safe, both way. You need to see that, okay, how much customer can wait, and are we having the enough capacity or management of demand versus capacity to ensure the acceptable wait time for our stakeholders. That's it. Maybe we do this time incrementally. I know this was a little heavy principle. So the similar exercise we were doing before, maybe we do only for principle 6 as of now. And then I talk about principles 9 and 10, maybe once we come back from the breakout room. Maybe we don't do activity for them.